Hi everyone, this is Renee Garcia. I'd like to tell you about the scientific method. The scientific method is actually a set of steps established to provide guidelines to prevent bias and false information, and it is based on two important concepts. The first is hypotheses. This is a provisional and untested explanation of a phenomenon which requires verification, which means that it's never been tested before and it needs to be in order to be proven. A theory is a hypothesis that has not been tested. Hi everyone, this is Renee Garcia, and I'd like to talk to you about the scientific method. What is the scientific method? It is essentially a set of steps established to provide guidelines to prevent bias and false information. So essentially, we're looking at guidelines that will allow everyone to do the same format, the same process, across cultures, across languages. This means that a test done in one country can be done by another group of scientists in another country by following the same steps, and the results should be the same. It's based on two important concepts. The first is hypotheses. The hypothesis is a provisional and untested explanation of a phenomenon which requires verification. So essentially, when someone has an idea about something and they say, well, my hypothesis is that the square foot of this area is going to be 160 square feet. That is a hypothesis because they haven't yet tested or measured in this case. Theory is a hypothesis that has been tested and proven. This is really important. It helps organize and predict how new facts may fit into the established pattern. So, for example, one of the biggest mistakes I see regarding science in television, movies, and writing, fiction and nonfiction, science fiction, is the use of theory in place of hypotheses. So often you'll see on TV, even like shows like Dexter, for example, oh gosh, they ask Dexter, well, how many people do you think could have provided this much blood to this crime scene? And Dexter says, well, my theory is 2 or 3. But he used it incorrectly because theory is actually meaning that it's proven. So if he knew exactly that there were 2 or 3, then he would say 2 or 3, because that would be the theory. But because he's only hypothesizing, he should have said, my hypothesis is 2 or 3. There are very specific steps. Now, these are the way the steps work in order. And this is simply because this is the way it happens to work in this order. So the first step is that you actually see something, you observe something, or you hear something, and you want to find out if it's true, or you want to find out how it works. So this means that you see something happening and you want to test it. So for example, I was always curious why yawning seems to be so darn contagious. So I want to make observations. I want to learn more about it. So one of the things I learned is that yawning is so contagious that talking about it, even as I'm talking about it now, you will likely yawn. When you yawn, if someone sees you yawn, they will yawn. I've even yawned after I heard someone on the radio yawn, and I've yawned after I've seen a dog yawning. So we're talking cross-species contagion on a crazy level, okay? So I want to research the observation. I want to find out, why do I yawn when dogs yawn, or why do I yawn when I even hear it? So I read books, read articles and journals, etc. So one article said that people yawn because they were attracted to the other person that is yawning. Well, in 2 of these cases, one was not a person and one was on the radio. So that hypothesis was clearly not proven and did not support what I was seeing in the observations. So I want to then form a hypothesis, and the hypothesis is a statement. It's not a question. This is a very big difference. It's a statement because you're either proving it or you're disproving it. A statement is proven or disproved. A question is up for any answer. So if I were to ask the question, do maggots arise through spontaneous generation on spoiled flesh? That means that I would have a multiple ways of pursuing that question. But if I make a statement, it's very clear. Maggots arise through spontaneous generation on spoiled flesh. So I have to prove that, or I disprove it. So first I want to do is identify variables. And variables are important because it helps to keep the parameters of your research or your study. Because if you don't, and you ask a question, like I said, you'll be thinking of dozens of ways that maggots might spontaneously generate on spoiled flesh. So we want to keep it in a very tight sphere of work. So variables, there are two kinds of variables. The first is independent, and independent variables are those that are within the context of the study. It's about the data you collect and what you collect. So is the what can be controlled in the experiment. So in this case, if there are maggots appearing on spoiled flesh, is the spoiled flesh outside or is it inside? Is it in a container or a closed container? Is it really, really hot or is it really, really cold? Is it humid, etc.? So all of these are variables that must be and can be controlled in your study. Whereas the dependent variable is basically one thing. What are you testing? Well, we're testing the presence or absence of maggots on spoiled flesh. Then step 4 is testing the hypothesis. So usually this means that you're going to experiment with the data and the variables that you've included and then determine if your hypothesis is correct or not. So in this case, we have maggots on spoiled flesh. They are outdoors and it's very humid and it's very hot, which means that the spoiled flesh is going to be very stinky and it's going to attract flies. The flies are going to lay eggs and that will become the larvae, which is known as maggots. Now, there's nothing spontaneous about that. Now, if we were to have the other parameters of the study and it's in a closed room, in a closed container, and there are no flies in the room, then the flesh will not spontaneously create maggots. It just won't happen without flies. So then we draw our conclusions using the trends in the experiment, and then we have our observations, and we ultimately have our results. Okay, so that's the experiment. Now, let's go back to the idea of science then. So we've gone through the scientific method. Science itself is quite old. This example, well, this individual here, Nicholas Copernicus, lived from 1473 to 1543, and his work included very early astronomy. So he determined that the Earth revolved around the sun. Now, because of this work, he was considered a heretic. He was condemned by the church as a blasphemer and a heretic. And though he wasn't put to death, he was very chastised by the church and by the king. Now, in this case, the problem was essentially that he did not uphold what the Bible stated as humans being the center of the universe, particularly man-humans being the center of the universe. So when he said that the earth revolved around the sun, he changed that paradigm, and that you cannot do. Up until, I would say from about the 1940s to the 1970s, or actually maybe even further back than the 40s, maybe even into the early 19th century, scientists were looked upon as sort of like these superhero characters. They were bringing about these significant changes in the world, the automobile, electricity, And eventually we get the atom bomb, and we get vaccines, and we get all of these things that make our life better, and in some cases, obviously like the atom bomb, not so great. However, the thing is that during this time, scientists are bringing in new research, and they're seen in a very positive light. But it wasn't until George W. Bush and his presidency where the term sound versus unsound science brought forth. Now, this is the first time since the 15th, 16th century, or 17th century as well, with Darwin as well, that we're looking at science as something other than a non-biased way to examine and research information. With his terminologies of sound versus unsound, and he used these mainly with regard to global warming and stem cell research, by designating what he proposed as good science, bad science, and well-supported and unsupported science, he basically made them seem untrustworthy. So science became untrustworthy, and scientists became untrustworthy. And this continued until we got to Clinton and his funding of the Human Genome Project. After Clinton, we go Republican for a little bit, and so it goes back and forth until we get to Trump. Now, there is a quote here that George W. Bush has exhibited hostility to science that no other president has ever displayed. This was during George Bush's presidency. However, during and after Trump, Christine Todd Whitman, who headed the EPA under George W. Bush, said of Trump, "I've never seen such an orchestrated war on the environment or science." And so with Trump, we have a renewal and a vehemence of science to a degree that it is the negative, untrustworthy information by uncredible, untrustworthy scientists. So that has taken a huge toll on the American perspective of science in general. So I hope this was a helpful lesson for you. If you have any more questions, please do email me or stop in my Zoom hours. Bye.